Everybody. So my name is Craig Mellon, and today I want to talk about how to introduce 3D design. So this is for beginner level people who maybe their kids have never done anything on 3D design or just a little bit. If you're using Blender and Fusion 360, this is probably going to be a little bit below you. But if you want to try to figure out how you can incorporate a new activity into your classroom, if you have a 3D printer available to you and you're just not sure how to use it, this is going to be sort of a good start. This isn't for people who have a 3D printer. We'll talk some about 3D printing, but this is also good for any classroom where your students have devices where they want to be creative and work on some new designs. So that's what we're going to talk about today. I've got my bit.ly here for the presentation. If you want a copy of it, the QR code goes to the same place. So I'll leave that up here for a sec so everybody can get onto it. This is also available on the MACE page for my presentation. All right, is everybody good? I don't want to leave anybody behind. Okay, I want to, has anybody ever used Menti before? Menti is a cool little tool. So I just want to get some feedback real quick to see where everybody's at 3D design, 3D printing wise. So if you go to menti.com and use this code, you're going to be able to enter a term or a sentence. But what is your experience with 3D design or 3D printing? I know some schools have 3D printers all over the place. Their science classrooms are full of them. Some might not have any. Our school has two, one that's working and one that we have some issues with. But I would say in our building, there's not very many teachers who feel comfortable utilizing that 3D printer, just a handful. So even if they're available, it might be something that's still a little bit maybe uncomfortable to use or something that feels a little bit out of your reach. Menti, if you've never used it, there's all kinds of features that you can have students or your audience create. There's word clouds, there's polls, there's all kinds of stuff. So it's free, it's easy to use, and I think it's a good way to get quick feedback. So a lot of people with not much experience, some people have a 3D printer, don't use it too much. All right, so this will be perfect for everybody. Wonderful. So my goal today is to give you experience with a tool called Tinkercad, which I think is the most user-friendly beginner's 3D design program. And it's a good way to get yourself or students a foot in the door for 3D design. And then it can open up a world of much more complicated software and all kinds of possibilities. So I'm Craig Mellon. Like I said, I teach at Clearwater Intermediate Middle School. My main role is as a social studies teacher, 6th grade history, but I also do some 3D design, introduction to coding, and robotics. So we have our big robotics competition tomorrow at Wichita State University. So I hope my kids, the past 2 days, have gotten all ready for that. We'll find out tomorrow morning.
What kind of robotics?
Lego Mindstorms.
Lego Mindstorms.
Mm-hmm.
Cool.
Yep. So we'll see. Yeah, I don't know. Either they're going to be doing really well the last 2 days, or everything fell apart, and I have no idea which right now. So here's my objective for my session. We want to examine methods in which 3D design with Tinkercad can be used in a wide variety of classrooms. So Tinkercad is aimed for grades 3 and up. I think in some situations it can maybe be used a little bit younger than that, but it can be a little bit tricky to learn for really young kids. But we want to see how we can use it in a lot of different classrooms, not just the 3D design room, not just a CAD room, but in any classroom throughout the building. All right, so just a real quick introduction on what Tinkercad is.
Oh, hi. You like making stuff with your hands, right? Well, have you ever wondered if a computer could help you make even more? Then you should know about Tinkercad. It helps you make just about anything your imagination can dream up. Watch this. From the very first click, you're making stuff, a thing, a mess, anything you want. The best part is, Tinkercad helps you take your designs out of me and into the real world by showing you how to 3D print them. Laser cut. Build them with bricks. Or make things light up and spin. Why? Because with Tinkercad you can. And because keeping things flat is boring. Sign up for Tinkercad now. It's free and works on any computer with an internet connection. Not to mention, it saves your designs for you up there. Be a change maker and join the growing community of curious doers in the 3D fun revolution, Tinkercad. From mind to design in minutes.
So Tinkercad is produced by Autodesk, who makes all kinds of industrial level, professional level software, but they've also brought that down to a beginner's level with Tinkercad. And as you see, they've got tools to 3D print, to laser cut. They have a circuitry software built in where you can work with different circuits and switches and Arduino. Now that's not something that I spend a lot of time with, although it is pretty interesting to me. The side I use the most is the 3D design, 3D print side. And so whenever I teach my kids, we're going to begin 3D designing and looking at 3D printing, this is always where we start. So what is Tinkercad specifically? It's web-based, so you can get to it from any device, any computer. At my school, we're Chromebook-based, so my kids are one-to-one, and they can just use their online, use Chrome to get to Tinkercad. And it's nice because then they can also, we don't take our Chromebooks home, they can go home on their own device, log in, and get to all of their designs saved in the cloud. It's completely free. There's no upgrades, no premiums. You know, you're not going to use a base feature and then a week later it's going to ask you for a ton of money to use it. It's completely free forever when you sign up. It's a beginner level tool. Now you can make some pretty advanced stuff with it. Once you learn how to use it, you can go and pull designs from the web. So you can make some pretty advanced stuff. But for a complete beginner, somebody who's never done anything in 3D design, this is where I would start. There are tons of built-in tutorials, projects, lessons, objects that you can use. So if you as a teacher have no experience with 3D design, you can just go step by step through Tinkercad's lessons and it's going to teach your kids what to do. So getting started. And by the end of today, if you want to create an account and get set up and play with it a little bit, I'd like to see that. I know when I go to one shop and see a new tool, I always want to play with it. So hopefully we have some time for that today as well. So there's a couple kinds of accounts that you can sign up for. One's an educator account, and you can also have a personal account. So the educator account is great because, and I'll show you in a sec, you can see all of your students' designs immediately. You can have access to what they're creating. The personal account, you can still see their designs if they set it to public, but it's not confined in a classroom environment. The students, you can create their accounts from your educator account. And if they're younger than 13, this is what you'll want to do. If they're 13 or over, the students can create their own personal account. They can do it if they're younger, but you have to go through and get parental permission. But the class account, it doesn't save any of the student data, so you can do that through the educator account the class created. And then we'll look in a second. There's tons of lesson plans. There's posters. There's information letters to send home to parents. All kinds of stuff in their teach section. So that's kind of what I want to look at next. And I want to show you sort of what Tinkercad looks like. So, you know, if you want to go to tinkercad.com, you'll be able to see all of this yourself. And you already have an account, great. If not, now's a great time to create one. So this is my sort of teacher profile page. And I'll show you some of my student designs here in a little bit. But under this Teach tab, there's all kinds of resources from classroom decorations to how to start a maker program. I know a lot of schools are building maker spaces where kids can be creative and build new designs and use new tools. And so they've got guides on how to help build that space in your school. But there's also tons and tons of lessons, from beginner lessons on how to move objects and create objects to building projects. And I'll show you as a history teacher, there's some in here that I really like. There's Egyptian hieroglyphics and cartouches and just a lot of stuff that fits into different content areas other than just for 3D designing to learn the 3D design. And then finally, there's big projects. So as the kids get more advanced, there's challenges that really let them be creative and explore different problems. I've had kids spend forever trying to build their dream house in Tinkercad. Because it's never perfect, right? Their couch isn't big enough, or they want a bigger TV. They have to figure out how to build the best swimming pool they can. So it's a way to really let kids have ownership and be creative. And it's all built within the Tinkercad website. So you don't have to create any of this stuff if you don't want to. And obviously there's tons that you can come up with on your own as well. Now, why introduce 3D design? So let's say you're in a science classroom. Why might this be an important tool for your kids to learn? Well, they can learn some personal skills through 3D design. First of all, just the idea of designing and prototyping, using that engineering design process. If you have a challenge, you have a problem, thinking of ways that you can solve that problem, designing something. If you have a 3D printer, you print it out, test that design, and then go back to the drawing board to improve upon it. Spatial awareness. When we start playing around with Tinkercad and building some models, all you'll see there's a work plane, and the kids have to really be aware of how these shapes interact and how one shape might affect another one in sort of a 3D space. Problem solving. This is one that I really see a benefit of. My kids, when I give them a challenge, most of the times they fail the first time. One of my favorite lessons in Tinkercad is it's got step-by-step instructions to build a little whistle. And if you design it right and stick it on a little PVC pipe, it turns into a flute, and it sounds pretty cool. But if you mess up at all, if you're even 1/10 of a millimeter off on your design, either it's not going to fit onto the pipe or it's not going to make any noise, and you're just blowing air through a pipe. And so the kids, they know right away if they fail, and they go back to the drawing board, they try to figure out where their mistake is and solve the problem. So it's sort of got this natural problem solving in 3D design. And the student ownership of learning, when they're creating themselves, they're in charge of what they're creating. They're in charge of their learning. Instead of filling out a worksheet or being a passive learner, now they have ownership. This is their design, this is their creation. All right, so career training. 3D design, additive manufacturing, all of these, 3D printing, all of these things are becoming more and more common in modern careers and in modern jobs. One of them is animation, so we've got Woody from Toy Story up there. This is the 3D model that Pixar used to animate Woody. They use some pretty advanced 3D animation software, more advanced than Tinkercad. But if students get into their 3D design, there's free tools that they can go grab, one called Blender, that can make these designs. And Pixar's actually released some of their software, some of their older software for free. So students can, for free, if they get into this, go out and get these tools on their computer, if they have a computer that can handle this software, right? And they can learn animation exactly the same way that the animators at Disney and Pixar and any studio are using today. Engineering. Engineering, design, architecture, all of these careers use some sort of CAD, computer-aided drawing, and 3D design. Now, architecture, like I said. Now, architecture uses, well, it depends on the firm, but they use a little bit different type of software than Tinkercad. We'll talk about how Tinkercad works in a second compared to other softwares, but there are free softwares that work more similar to what architects would use. Manufacturing as well. So I'm from Clearwater, which is down by Wichita, and Wichita State has enormous new laboratories that tie real closely with some of the factories and businesses down there in Wichita, which a lot of them are based around the aircraft industry. And there's incredible labs now that use just 3D design, 3D scanning, 3D printing to build incredible parts for airplanes, all kinds of stuff, just with 3D design. So that's something I think is going to become more and more common as time goes on. And finally, medicine. And this is something that I've just noticed recently. So maybe a year or so ago, I had to get a crown put on my tooth, and the dentist used a 3D scanner and carved a cap of filling basically for my tooth right there in his office. We've got a student who I'll talk about a little bit today, who a year ago was in a really bad car accident. Had a lot of brain damage and some really serious issues. And I was talking to his mom the other day, and she's got a 3D printed model of his skull that the doctors scanned and 3D printed to see exactly what was going on with his skull, where it was broken, and so she's got that model at her house of his exact replica of his skull when it was fractured from that accident. So I think in even medicine, 3D design, 3D printing is becoming more and more common. All right. I want to talk about some content ideas now, and I'm going to share some ideas, and I hope that I hit some of what you do. Raise your hand, raise your hand if you're a classroom teacher. Okay, raise your hand for your elementary level. Middle? High school? Raise your hand if you're not a classroom teacher.
K through 5.
K through 5.
Technology.
Okay, good. So hopefully we share some ideas here that everybody can take something away. And I'll, like I said, I'll come back and show you some of what my students are doing. But I'm more of an expert in history, so I have more ideas there than anything else. And hopefully you can spark some ideas of how to use this 3D design. And it may not be a specific 3D design project. It may be something that you allow your kids to learn, and then they're trying to show their knowledge, and this is an option that they have. So maybe, they can write a report, they can make a video, they can, make a 3D design. This is, I think, just another tool in our toolbox we can use. So ELA, and the designs you see here are stuff my students have made throughout, the past few years. But let's stand up here. The first idea that I've seen students use is character design. So in the bottom left-hand corner, it's a horse. And a student of mine was studying the Iliad, the Trojan Wars and the Trojan horse. So she was designing a Trojan horse. And I told her I was going to throw it on this presentation, and she was really upset. It's not done. It just looks like a horse. It doesn't even look like a horse, she said. It looks like a llama. And I think it looks fine, right? And the goal of this isn't to have her see how well she can 3D design a horse. It's to study the material, find evidence of what's going on in the story, and then show that knowledge in a 3D space. Scene recreations. In the 6th grade reading right now back home, they're reading a book called The City of Ember, which I don't know a lot about, but apparently it takes place sort of in this underground city without much light. And so they're doing sort of a project with it, and there's a couple students who are trying to sort of build that underground space, build that scene, that city, based on different facts and information from the book. And physical propaganda. So this is something that we haven't tried yet, but it's an idea our reading teacher and I have shared recently. But one thing that they cover and discuss is propaganda. So they look at different types of propaganda from the past and how it's used. And so one of the things she wants to try is to have her students make some 3D model that somehow utilizes those aspects of propaganda. Up in the upper right-hand corner, and this is something we've done with some of our younger students, students can create easily their names or a piece of writing, Christmas ornaments and things like that. So if you're working on spelling, or even really young kids, writing their names, spelling their names out, I think this is a kind of cool thing to do, that they can, if you have a 3D printer, physically print that and have something that they've created based on their learning. All right, math. Math is, in a lot of ways, tied into this naturally with measurement, with location and relationships of shapes and geometry. But here's a couple specific ideas that we use. One's visualizing fractions. So introducing fractions and understanding what those fractions are showing is difficult for a lot of students. And there's a lot of different ways that, the little pie pieces are just a pretty easy example, that students can go in and visualize what these fractions are saying. If you just see a fraction written out, a lot of times for students that can be pretty abstract. But visualizing them and having the students create something that shows those relationships between the fraction can be a way to help them grasp the concept. Graphing, so there's built-in graphing features in Tinkercad to make 3D models of information and data. And this is something that students can easily take measurements and then build a graph that shows what that data is telling them. And finally, coordinate plane. So in Tinkercad, we start with something called the work plane. And this is just the base layer that students build on. And it's got a grid to it. You can change the grid however you want. It can be big or small. It can have, a 1 millimeter gap between the lines, or it can have a much bigger gap if you want, or much smaller. But students can use this to plot different areas like they would on a coordinate plane. And based on those plottings, build a shape. So if you give the kids a set of coordinates, if they're able to go in and put those spots or connect those dots, then they can go in and build a shape based on that. Science, I think, is an incredible area for 3D design. Like we already said, the medicine community, medical community using 3D design is already exploding. And I think the kids are able to build all kinds of models around their science curriculum. So scale models, first of all. Here we are on the screen, we have a DNA strand in an animal cell that students have created. The students didn't create the DNA, but this is something that they looked at and manipulated. A student did design that animal cell for a project. Solar system and huge objects you can scale down and model much bigger distances in a small space. Tiny, atomic particles can be modeled in a scale where they're much bigger and we can see them. Molecular bonds is something that when our teachers are introducing chemistry and introducing some of those early relationships among the particles in that we have in the universe here, they model them using Tinkercad. They can draw out the atoms bigger or smaller, connect them to make water molecules or any other molecule that combines different atoms. They can model within Tinkercad. And then simple machines as well. This is something that we've 3D printed some for some of our younger grades who are introducing and learning these simple machines, and they can have physical representations of these and see how they work, and even design them into space to see how a lever or a ramp might work together. All right, social studies. So this is sort of my bread and butter. This is what I like to do a lot of. And my students who really enjoy 3D design, 3D modeling, they will spend tons of time just on a project for their own benefit. And I'll talk about the girl this is her current design of the Parthenon in Greece, but she's spending hours outside of class, not because I've asked her to, but because she wants to research and design this and work on it and make it as perfect as possible. So there's some really cool things we can do with mapping on Tinkercad. It's got built-in shapes that are the different states or different countries on certain continents, and students can just grab that pre-made shape. So Kansas is a fairly simple shape, but maybe you live in a state like Hawaii, that's a little bit more complex. But they can take that pre-made shape, they can map on top of it, put objects on top of it, find where different locations are at. Same thing with the different countries of the world. There's also, outside of Tinkercad, Iowa State University has a program, some software that they've built that you can zoom in on any part of a map, on a global map, and it will take the topographic data from that map and create a 3D model showing that landscape. So you can go in and pull your hometown or the state of Kansas or the Alps in Switzerland and get a 3D model of that landscape. If you want to accentuate the height, you can. So like Kansas, if you print Kansas, it's gonna be fairly flat, but you can accentuate the height to show the elevation change as you go from east to west. And you can print a model of that state or that area that you can physically have and show the kids. Historical recreations. Does anybody know who this is? Yeah, it's Abraham Lincoln. So this is a life mask that was made of him in 1865 before he died. A lot of people think it's a death mask that they did after he died. He had this done while he was alive. And the Smithsonian has copies of that life mask. And the Smithsonian is currently working with Tinkercad to release 3D models of a lot of their artifacts. So you can go and get a 3D model of Abraham Lincoln's life mask, all kinds of different artifacts, and put it in Tinkercad and model it and manipulate it. I don't teach American history, I teach ancient civilizations, but if I was teaching the Civil War, this period in American history, I think how cool it would be to pass Abraham Lincoln's head around. And it's an exact copy of his head, they molded his head when he was alive, and this is a 3D scan showing that exact shape. There's also historical recreations. Like I said, my girl built in the Parthenon. We're studying ancient Greece now, and one of the projects we were doing was studying their architecture, and she wanted to use 3D design to kind of show off their architecture. So she started to build the Parthenon, and in a second, I'll show you her first copy, and it kind of looks like a Greek building. And it's all right, that's cool. And then I asked her questions like, is that the right number of columns around the Parthenon? And she said, I have no idea. And I knew it wasn't, right? She had just kind of guessed and made it look similar. And so in her second design, she's found blueprints of the Parthenon. She's measured out the columns, how many there are, measured the interior chambers, and she's not finished yet. This is her current progress. But she has found an interest in this. And so she spent tons of time outside of class researching the Parthenon, ancient Greek building, and building it in 3D design. So some kids, this is an area where they're going to get really involved and really interested. Whereas if they're writing a paper about the same topic, they may hate it and just drag their feet and not get it done. Now some kids may not like this as much, but that's why I think it's important to have options. Okay, and this is one of those pretty cool options. All right, artifact studies as well. So this kind of goes into what we've already talked about. But the students can go research some artifact, some object, and 3D design it. Now, through that 3D design, they've got to research the artifact. And they'll make a model of it, and at least my students, the first time they do it, it's not very accurate. And so I'll poke them, I'll prod them, I'll say, okay, what size is that? How big is that? And they'll say, I have no idea. So they've got to dig a little deeper. They've got to find the dimensions. They've got to do more research to get to know that artifact better. So the 3D design is just a tool to get them to do that research, find more details, and get a little bit more information. All right, now Tinkercad has some additional features, and I'll kind of show these off here in a second. Outside of 3D design, Tinkercad has added, and this is pretty new, this is still, I think, in beta, but they've got a code blocks feature, so they've got a coding side of their website that you can build this block coding and tell it how to build or how to manipulate the objects on the work plane, on the screen. And so this is something that if you're trying to learn coding, it's another easy tool that kids can use to sort of learn these different features. It's not something I've played with too much. Like I said, it's pretty new, but it's a new feature that they have. Something else that I think is really neat, especially for people who have a makerspace or trying to expand a makerspace, is their circuits. And so this was created in Tinkercad circuits, and there's all kinds of different tools that you can add in, like switches and dials and lights, Arduino, and different breadboards and circuit boards, and you can build your circuitry, you can build your electronics, test it, and then after you test it, you can go and build that model in actuality, and it should work if it worked in Tinkercad. There's also some, we've had some of our kids do these Minecraft mods, so if your kids are into Minecraft, they can build stuff in Tinkercad and upload it into Minecraft, into their space that they're living in there in Minecraft. Now, I'm not a big Minecraft guy, I don't know a ton about it, but the kids who are into it spend tons of time on Tinkercad building and then uploading it into their Minecraft world. All right, so let's look at Tinkercad a little bit here. So I kind of want to show you the sort of the basics of creating in Tinkercad. So we'll create a new design, and I always tell my kids it's really good, it's really helpful to have a mouse. It's hard to use Tinkercad or any 3D design software without a mouse. And that can be difficult if your kids only have tablets or touch screens. Luckily, they can get a little mouse for pretty cheap, and you can get a school set for not too much. But it is something that might be the one hurdle I'd say to using Tinkercad is it's pretty difficult to use without a mouse. Now, kids are resilient; they'll figure out a way to do it. It's possible. It's just pretty inconvenient. So here we have our area, our work plane. Tinkercad automatically saves your work, but it gives it crazy names. Like this is Neat Jabbin, and I always tell kids to rename it because you'll never remember the crazy names it gives it, even though they're kind of funny. And here's our work plane. So our work plane is where we'll build everything. On the side we have our shapes, and there's two types of shapes. There's solid shapes, and then there's what's called holes. And so solid shapes are solid. And you can change the size, you can reshape them, you can change all kinds of stuff. These shapes with slashes on them are holes. And you can change any shape to a hole. And so what happens, the holes are kind of like knives. So if we select all of our shapes and group them together, that hole is going to slice through whatever objects it's touching.
How did you do the group thing?
It's up here at the top. There's also, you can hit Control-G, and what's nice, Tinkercad, they've got all kinds of keyboard commands that makes life a whole lot easier. And they've got printable sheets that you can hang up or posters that show all of their keyboard commands. The one that I think is the most important for any type of creation online is Control-C, right? Undo. Once the kids learn undo, they know it's okay to make a mistake. I didn't want to cut that, right? Control-Z.
Before you cut it, did you, one was on top of the other one?
Yep, so I just stacked them together.
So you put one and then put the other?
Right.
The other one, and then when you click on it?
Mm-hmm. Oh,
Sorry.
no, that's right, I think I hit the back button. Let's go back into our design. Yeah, so you can, there's infinite ways to connect these shapes, and that's where you can get some pretty complex designs. So all
You
I'm,
had to put a square.
yep, I'm selecting them both, and there's multiple ways to select. If you just click and hold shift, you can select objects by clicking on them. And then the group command is up here, and that will unite those shapes, and since one was a hole, it's cutting through the other. There's, you know, let's say we wanted to have a rounded edge on this shape, right? We could add a cylinder, we could connect it however we wanted, and again, when we group it, it's going to unite those and make it one shape.
How do you do things vertically? Like, let's say I didn't want the hole to go all the way through.
Yeah,
Can
good
I
question.
put things below the plane or?
Go back and do it. So, to manipulate the objects, there's, you know, your sort of normal resizing squares around here. To lift it off the work plane, there's this sort of cylinder cone at the top where we can lift that up and down. And one of the most, I think, helpful things, or one of the things that kids learn the quickest in Tinkercad is measurements. You have to be able to look at your measurements and dimensions. And so as I'm raising this up, you can see that dimension at 7 right now on the side. That's telling me how high this object is off the work plane. If I want it to be, if let's say I wanted to cut a 1 millimeter hole in this cube, the first thing I gotta know is how tall my cube is. It's 10. So then the kids gotta figure out, all right, so then this needs to be 9 millimeters off the work plane. So when I group it, it only cuts a 1 millimeter hole. And so those kids, they have to come up with those exact dimensions. We've got, my principal we've had some construction done. He brought this sort of old TV stand that he's turned into a coffee bar to put in this office. And he had to cut a hole into the coffee bar a certain size to, I don't know, pour water into the coffee machine. And so he asked me to do it, but I gave it to my kids. He wanted a 3D printed piece that would sort of go in that hole, make it look a little bit cleaner, make it look a little bit more finished. And so I gave that to my kids, and they had to come down, 2 of them were working together, and they had to measure that hole, figure out how deep it was, the size of it, come back and 3D design it. They realized that some of their measurements were right, but they put stuff in the wrong spot, so they had to kind of go back and forth to refine their design. But if your kids are learning measurement, this is a great way for them to figure it out.
Can you change it to?
You can.
The bottom inches or whatever?
Yep, so it's automatically in millimeters, and we can change that. So when we click edit grid, this is the grid of the work plane. We can change it to inches or bricks. So bricks would be like Lego. So you can tie Lego into this as well. But if you want inches, you can do that. You can change the size of the work plane. So if I wanted it 12 inches by 12 inches, we could do that. There's specific 3D printers. If you have one of these 3D printers that works, you know, their company works directly with AutoCAD or Autodesk and Tinkercad, you can use that, but unless you have one of these 3D printers, it's not real helpful. But that'll update the grid, and so now when I resize objects, I'm resizing it to inches. So if I want this to be 1.5 inches, you know, I gotta put in 1.5. This is another great way for kids to switch fractions from decimals to fractions, right? If they're using a ruler and say, okay, this has to be 2.5 inches, it'll show, right? It'll show me a fraction, 1 1/4 here, but when I type it in, I gotta type in a decimal. So I've gotta be able to know that 2.5 is 2.5. So it sort of creates a need for kids to have that knowledge. And if they already have that knowledge, it forces them to practice and refine those skills. Let me show you some of the designs my kids made, and we'll kind of tinker around with some of the stuff here. Tinker. Here's that Abraham Lincoln mask. Now, we didn't design this, we just pulled this off of Smithsonian. But Smithsonian's got tons of different models that you can go get and tons that are available. They're still scanning all of these objects, so they've sort of made it a mission for them to release as much of this stuff that they have for free as possible. And now I could manipulate this and do whatever I want. So what might be neat if, you know, kids were studying Lincoln and they found this, they don't really have to learn anything about Lincoln to go find this model and plop it in here. But, you know, I might say, okay, now create a base or plaque for it, like this is gonna go in a museum, put some information on it. Under our shapes here, we can change to lots of different shapes. So here, you know, under featured, there's tons of different stuff that the kids, there's tons of stuff that you can go get to and the kids can design with. Here's where we're gonna get the states. So you want the kids to map out the United States, okay? Here's New York, but if I don't want New York, I wanna flip it to, you know, Alaska. It's going to change it to Alaska and it's going to resize it. Now, I haven't messed with Alaska much, but the other states, it scales them properly. I'm guessing Alaska is supposed to be so big that it wouldn't fit on your map. But this would be a good way for kids to scale and see the different sizes of the states and map things on the states as well.
So if you wanted to like group that hit, can you group other stuff with that shape?
Yep, you bet. So let's give them a hat or something, right? So they've got some shapes for characters. Maybe we want Abraham Lincoln to be wearing shades, right? So let's give them some sunglasses here. Okay, and I want, you know, the sunglasses. Oh, I'll show you another neat tool here. I want the sunglasses to be centered on his head. And maybe I'm having trouble doing that. If I select both of the shapes like I'm gonna group them, there's a tool up here that is the align tool. And it gives me some dots. And so this helps me align them. So if I wanna align them, both of these shapes right in the center of his face. I'm gonna click this center dot in front of his face, and it's gonna line those glasses up right in the middle of his face. Now, you know, I don't know if Abraham Lincoln had a symmetrical head or not, but if he does, then these glasses should fit just right. We can also rotate the shapes. This is something else that's good for kids. It's working on degrees of a circle. So if I want to rotate this shape so it's down on his ears a little bit more, I can use this rotate tool to find that exact degree. A lot of my kids learn pretty quick that they've got to rotate things exactly 90 degrees most of the time. If you rotate something 87 degrees, it may look right to your eye, but when you try to group it with other things or make a model of it, you're gonna realize pretty quick that stuff's not fitting. So if we wanted to group Abe Lincoln here with his glasses on, select everything and group, right? And now he's got his shades. You can change the colors. So if I want everything to be the same color, right? I can just change the color of that object.
Does it automatically put it on a build plate, or do you have to say like, put it on a build plate?
For like 3D printing, you mean? So we're gonna talk about 3D printing here in a little bit, but let's talk about that. No, you're fine. When we export the design, you can choose what file you need. So I personally use STL, a lot of people use OBJ. If you're designing something to be laser cut, it's got that file type as well. So you export your design as that file type, and then whatever slicer you use for your 3D printer, you know, you can put it in that design and you can fit it on the build plate however you need based on your printer. So Tinkercad itself doesn't do the 3D printing framework and power, so you take it from Tinkercad to put it into
Well, I
whatever.
printed stuff from like Thingiverse,
Okay,
but I'm trying to have the kids do their own things.
sure.
I was just wondering about the build plate.
Yeah, Thingiverse is great. So it's kind of similar. So when you download this as let's say an STL, that's what you would also download from Thingiverse. It's the same file type.
And I've actually like classroom, they've done this, so I put their files as an STL and printed them.
Yeah.
I'm trying to have the other kids make designs.
Sure.
And I was wondering about the build plate, if there's a way to put a build plate?
Yeah, so every printer's different.
Yeah.
So Tinkercad just gives you the model, the object.
Yeah.
And then whatever slicer software you use for your 3D printer, so whatever
Put
software.
it there.
Yeah, then you just upload this file into that software. And it's the exact same way you would
don't
do it
have to
from
Put it in
Tinkercad.
here, you don't have to design it with one.
There's no way to drag the workspace, right? You can't, I'm trying to orient, even just slide the workspace up and down and just does the select screen.
Yeah, you can, and that can be helpful. So back to your question, what kind of printer do you
And they
use?
go out and eat.
Okay, and so they have, do you know what slicer software you use?
Well, I always download it as STL.
Right.
So is that the same?
It's the exact same. Yep, you would do the exact same thing. As far as the work plane, let's throw a cube on there. I think that's the easiest way to show this. If I want to put something on top of this cube, I forgot my wireless mouse at home, and I went to Best Buy last night to buy a new one.
Mm-hmm. Yep.
And it doesn't like me very much. You can put a temporary work plane on any object or on any surface. So up here where the work plane tool is, I can put that on top of my cube. So now I'm building on top of my cube. If I want to build on a vertical plane, I can put the work plane on a vertical plane and now build on this surface. So now if I'm adding an object, it's adding on this surface.
Okay. I just mean almost just like moving around the workspace. I have to zoom in, zoom out every time.
Yeah. so
That's
the-
what I
I think
mean.
it's option.
It's
it-
an option.
I got it.
To just.
You mean like I just want to move my work plane to the left, but instead it draws a square for me.
You got it. So that's where a mouse is really, really helpful. Because then you can use your scroll wheel and both clicker buttons, the right and left mouse button to move. It's very difficult to move around.
Oh, I see. I could 2-finger click and manipulate it that way.
Yeah.
Okay.
There's also,
Okay.
I'll go back into the design here to
But
show
still
you.
doesn't let me just like slide the work plane.
Right. With the mouse, you could. And that's where I keep hitting this mouse has a left and right click button on the scroll wheel. So when I usually back at home, I'll click the mouse wheel and just click the scroll wheel and let me drag the work plane wherever I
Okay.
want. There's also a cube at the top,
Yeah.
which lets you adjust the angle. You can also switch to a flat view, which gives you a perfectly square view of your image, of your object. But the best thing I say is get in there and play with it, go through some of the tutorials and go through some of the lessons that they have. And what you'll probably learn, at least I have, is the kids who are interested in it and really get into it, they will quickly move past your experience and knowledge level. And that can be tricky, right? I want to help these kids, but they know more than I do. Let them go, and if they're interested in it, if they really have that problem-solving ability, they're going to find a way to figure that out. All right, so before I wrap up, I want to talk about 3D printing just a little bit, just a minute. So this is a great way to bring your students' designs to life. And once they can physically see their object, it sort of brings on a whole new level of meaning for them. It also raises, I think, the level of engagement because they're not just designing this in some cloud space, in some server, right? Now they're gonna know that my object that I'm making is gonna come to life. It's got real world problem solving. Like I said, those kids making that coffee thing. I'm gonna print it and the first one may not work. And I'm okay with that. I kind of hope that happens because then they gotta figure out what's wrong with it. Then they have to figure out what can they do to improve it, go back to their design, remodel it, and then hope that it works this time. And that's a big part of that engineering design process. That's a big part of STEM and STEAM and all of those acronyms. You can also find and customize classroom resources. So I've printed, like teaching ancient history, I've got a bust of Socrates. I've got a model of the Parthenon. I've got King Tut's burial mask, all in miniature. But these are things that I just went and found. If you use Breakout EDU, there's tons of different puzzle boxes and locks that you can print off and use. Just a unlimited number of resources online that you can go find and just print immediately and have them in your classroom. And sort of the last thing I want to show you here is something really cool that we've been doing the past couple weeks. So that boy I told you about who was in the car accident, he's a student who was extremely gifted, very, very bright. And for a long time after this car accident was unresponsive and in a coma, and he's really miraculously kind of come back, and a lot of his intelligence has returned. But one thing that hasn't returned is his sight. And so he's learning Braille, and he's learning to live without his sight. And one thing that our gifted teacher found was something called Fiddle. And it's a project that's given all these free 3D printable models and resources. And this is one that we've used. Does anybody know what this is? Anybody read Braille and can read that?
Fish.
Yeah, it's fish, and that's what the letters say is fish. And so this is a 3D printable puzzle, and it's in 4 pieces to say fish, right? So he has to read the Braille letters and figure out how to snap together. And so our gifted teacher thought this would be a really good idea, and I thought it was as well. So I 3D printed a simple one I found just to start out, and it was pig. And so he's an 8th grader. I gave him these puzzle pieces, and he snapped it together easily, and just made fun of me completely for giving him one that was way too easy, for giving a pig. So I went in and found one that said Zeppelin. And so that one's 3D printed now. I'll give it to him when I get back, and I'll teach him a lesson, right? So this is sort of the most real world application I've ever seen in my classroom for 3D printing. Being able to give this kid the experience of problem solving and puzzling while still learning these concepts of Braille. So he's you know, intelligence-wise, he's way up here. But sight-wise, he's still learning just at a really basic level. I think this is a really good way to kind of unite those two things. If you've got my presentation, you've got a lot of these resources that you can get to. SketchUp EDU is another free 3D design tool if you have the G Suite, if your school is a G Suite school. Instead of using objects like the cubes and those 3D shapes, it uses, it's line based. So you draw everything based on lines and make 3D shapes that way. And then a lot of other resources that you can get in and check out. My email, my contact information is on Mace's website. It's on my presentation. If you have any questions, let me know. Is there any questions before we leave? Get to our last session of the day, I think.
So when you start this with students, I know like I'm just using the app from the iPad.
Yes.
Like all of the training and stuff, does it usually you have all your students go through that, or
Yep.
you just?
So I've got one of these things. This introduction video is just a little thing I've made that I have. If my students are trying to learn it, I have them watch. It's just me, on a screen test. But back in Tinkercad, they've got this Learn tab at the top that the students see, and it's got lessons that go from a really basic level to some pretty in-depth design. So I have them starting off, go through these tutorials, and it just shows them how to manipulate the objects and work on the work plan. Yep. So that's always where I start with brand new students. All right, well, thank you. Have a great afternoon, and enjoy.